Example 6. In example 6, we're going to let y equals u times v, where u and v just represents two functions in terms of x. So it's u of x and v of x. And these could be any functions, it doesn't really matter what they are. And in this problem, we're going to be asked to find y prime of 2 if we're given specific values of u and v and their derivatives. So what we're going to do is we're going to write this as y is equal to u times v. And now it asks us to find y prime of 2, so we need to take the derivative. So we get y prime is equal to the derivative of the first times the second plus the first times the derivative of the second. And this is using the product rule because this is a product of two functions. And so we want to find y prime of 2, so we get u prime of 2 times v of 2 plus u of 2 times v prime of 2. In order to find y prime of 2, all we have to do is substitute the values in for what they are. So u prime of 2 is equal to 4. V of 2 is equal to 1. Plus u of 2 is equal to 3. V prime of 2 is equal to 2. And so we get 4 times 1 is 4, plus 6. And so we get our final answer is 10. So now on your own, I want you to try to determine the derivative of uv at x equals 0. So notice I'm not giving it to you as y equals, I'm just telling you to find d dx of u times v. Keep in mind that they are both functions of x. Alright, so we want to find the derivative with respect to x of u times v. So this is going to be equal to u prime x times v of x plus u of x times v prime of x. And we want this at x equals 0. So it's going to be u prime of 0 times v of 0 plus u of 0 times v prime of 0. And u prime of 0 is negative 3. V of 0 is negative 1. U of 0 is 5. And v prime of 0 is 2. So you get 3 plus 10, which is just 13.